All right. We were all treated to a fantastic IFT-10 launch by SpaceX of their Starship. It was quite the sight to behold, and almost a perfect 10, as many of you watching would have surmised. I've got Scott Walter with me. He's an aerospace and mechanical engineer and two-time founder of robotics company. Scott is always there to help us break down these complex subjects, and it's such a pleasure to have you, Scott, today to talk about IFT-10. You've got a few points that you'd like to highlight. I'm not sure many would have caught on to what really transpired, but that's where you come in, and that's where we rely on your expertise. So first up, your big takeaway.
The big takeaway is that finally SpaceX was able to hit all the mission objectives. So, and all these missions, the payload has been data, okay? And unfortunately, they were not able to get the data because of some unscheduled RUDs on the way up and on the way down, which was a bit disappointing because there were definitely some systems they wanted to check out, like the deployment of what they call the dummy links, as well as stress testing the new heat shield that they have. So they were finally able to do it. And even if it wasn't perfect, that's the whole idea, is they're trying to get the data to find out what they can and cannot do and where there are going to be areas of improvement. So they were able to hit all those mission objectives. There were a couple of bumps along the road, which is to be expected. And actually, some of those sort of showed the durability and the robustness of the system is maybe is a bit more than people would have expected. So the first thing to look at is, remember, this is a complex kind of launch. There's a lot of things going on. And the first thing is getting off the pad. So they're getting off the pad without a problem now. I mean, that has not been a problem since the very first one with the concrete tornado. And that was using old Raptors and everything else. And they're just like, they finally wanted to launch and use this stuff. But after that, it just keeps getting better and better. And you can see how smooth it's gone up. And there was no flame outs at all. All the engines performed fine. They went up there quite well. The other objective, of course, is the staging, which they had difficulty in the first couple of flights because they weren't quite sure how they wanted to do it. And they went to this idea of hot staging, which is a little bit more efficient, but also a bit of an engineering challenge, which required them to make a slight change to the booster. So the original booster, like what I have, I bought this thing about 2 years ago. And at that point, they didn't have the hot staging ring. Now you can buy the hot staging ring for the thing, but it's like $125. It's like, oh, come on. So the hot staging ring is because they need a vent in order for the to exhaust when the upper stage, when it decides to light up, you need some place for that to go. And so you need to have a vent ring there to be able to do it in the hot staging, because the idea is they're not going to have an engine shutdown in separation and then a startup. They want to have the booster still burning while the upper stage is attempting to light. Because if you just stop that, you actually get a little bit of inefficiency. So they've been able to demonstrate that quite well in a bunch of the flights. The thing is, every time the booster separated, it either went left or right or up or down. They did not have that under control. So what they've now done is they've come up with a way of actually being able to make sure it comes off the most efficient way. Because that was a problem, because it kind of randomly came off of the upper stage. They then had to correct for that, which meant that their return was a bit more inefficient. And now what they want to do is the most efficient one, and that is to drop straight down. So that's the perfect way to kind of drop off. And I think this is like the second time they've demonstrated that.
Right.
The disappointing thing for anyone that actually came out for the launch is that they didn't do a return to launch site. And at this point, they feel like we don't have anything to prove here. We know we can do it, but there's some things we want to do that are going to stress the thing. And that is, we want to see what happens with an intentional engine out. And that's not something you want to test over your catch mechanism. You want to, it's like, if that for something goes wrong there. So what they're doing right now is they're pushing the envelope to see what happens if you suddenly lose an engine randomly. Can you take up the slack very, very quickly and be able to do that? And that's why they've been doing that. The previous test, it didn't quite make it all the way down because they came in at such a steep angle of attack. The booster was not able to handle that. Again, that was a data point. I mean, they pushed it right to the edge. They found, okay, we can't go that far. We know where the edge is. Let's bring it in a little bit. They brought it down. They're able to get that to land. So the booster has really been performing quite well. I'm very confident with what's going on there. Now, everyone knows the upper stage, we've been a little bit nervous about because we've had kind of 3 failures in a row. We don't know why. And I think we know why, and that is it's an upgrade. And so what they say, if it ain't broke, don't fix it. So they kind of fixed something or improved something, and as a result brought in something that resulted in 3 straight failures. But this time they made it, yes, technically not to orbit, because they actually didn't want to go to orbit. They wanted it came down if something went wrong, but for all purposes they could have gone to orbit if they wanted.
Okay, so the relight of the vacuum engine, the vacuum Raptor, that was successful.
Yes, and that's very important, because it's one thing if we throw a really small payload up there and for some reason gets stuck in orbit, it's probably not going to be that hazardous when it eventually does come down. You put something like this up there, you want to be able to control when and where it comes down, and you don't want it to be stuck in orbit. And that means they had to verify that they can really do an engine relight. And they've already demonstrated that, I think maybe 1 or 2 times, but they want to do it one more time to make sure. Now that they've done that, there's a good chance the next flight they could actually decide to go into orbit and then bring it back that way. So it was so it was put in a type of orbit that the low part, which you would call the perigee, is actually inside the Earth's atmosphere. So it wasn't like a perfectly circular orbit. So it had the velocity that almost could have been there, and they could have circularized that easily if they wanted to, and gone ahead and made sure they're in orbit. But the idea is that you make sure that it's going to dig back in the atmosphere, and as soon as you dig back in the atmosphere, you're slowing down and you're coming home whether you want it or not. So that was the whole thing, is just to make sure it's a fail-safe, to make sure that thing comes down on its own. If they have enough confidence, it's possible on the next mission they will try that, or definitely the mission after that. And if that's the case, that means that next mission, the payload is going to be more than data. They're actually going to decide to leave something up there. And we can talk about what that is. Yes. So this was a test of what they call the PEZ dispenser, which is going to be dispensing the V3 satellites, Starlink satellites, through a very small bay door, or pod bay door, if you want to call it. It's technically not a pod bay, right? Because there are no pods out there, but it is a payload bay door that we're about to see open, because they had to do a little bit of decompression ahead of time, because you don't want to have everything go out, but there's still like a little bit of remainder, which probably chilled the air that resulted in condensation. And then you could see out into you could see being evacuated. Yeah, the final bit as it went out. So now they opened up, and it's a very thin slice, and it's to the right side of the picture. It was a little bit hard to see at first, but it's there. And now they're going to take these very flat, dummy Starlinks, they call them the dumb links, and basically just push them out into space, and push them out again, and push them out again, and push them out again. Now, if we quickly look down at what I think is the attitude, one thing that kind of surprised me here, and this is something that Scott Manley mentioned, and I'm not sure if it's correct, but usually he gets everything right. He says that they were actually pushing them out in the orbital direction. It's a little bit hard to tell from all the images, because we don't see anything from the outside. But if we look at the orientation of the Starship that they have down there and the attitude indicator, it may be that that's actually, I'm not 100% sure. I think the way it is, I would think it's going retrograde, and there's be a couple reasons for that. If you're pushing it out in front of you, it means you're going to kind of potentially run into them, which could be a danger. And the other thing is, you want these dummy links to also re-enter. They're not allowed to stay up there, because there's nothing on there. They didn't even have cameras.
But I think that was their stated objective, right? To eject them in the same orbit as Starship. So
the same orbit. The question is whether you're pushing them in the direction of travel or behind. Now, if you're pushing them in front, you're giving them a little bit of extra delta V, probably not enough that it would actually be able to go into orbit, but let's just say you're making it a little bit harder for it to re-enter. If you're pushing it behind, you're taking a little bit of delta V off of it, which means it's going to end up, coming down a little bit sooner. Now there may be a variety of reasons why they decided to do that, because remember, these guys at SpaceX, they understand these problems, and I'm just trying to understand, why they may have done it one way or the other, because there was an event a little bit later on after the deployment of these dummy links that some of the theories are it may have been that the upper stage actually bumped into one of these dummy links on the way down. So that's this skirt issue where there was a sudden impact of some sort or explosion in the skirt section of the booster. And so that's going to be the lower part down here where the engine bays are. There was a very energetic event that happened. and nobody knows what it is. And some of the speculations is it may have bumped into one of the dummy links. So let's think about that for a second. It's like, is that possible? It's always hard to tell what's the direction of travel here. But the first thing is that even though this is going very fast, it's going at what, 26,000 kilometers per hour. And the dummy links are also going 26,000 kilometers per hour. They're going that in the same direction.
In the same direction, right.
You're right. So the relative velocity is pretty small. So I would be surprised that you were having relative velocities that are like 1,000 kilometers per hour or something like that. It would be very small. It would be on the order of almost what they pushed it out there with, but a caveat, and we'll kind of get to that caveat for a second. So let's imagine that you're pushing these things in front of you as you're going down. Now, you've got a lot of mass in Starship itself. So when it hits the atmosphere, it's not slowing down at first. I mean, it's just going right through there as if it doesn't even exist. But these satellites, when they start hitting hitting the atmosphere, they're very light, and they're going to be like a piece of paper in the wind.
There's going to be a much greater
and they're going to exactly. There's going to be a huge braking effect on that. Now, this happened at some point when we're in there. I think it was like still around 26,000. So I don't think it slowed down that much. So it's not like, if it had already been very deep in the atmosphere and something silly happened that, they push these things out in front and one of them gets slowed down. And of course you run into it because it stopped really quickly, which is why I think they ejected them out the back, in the rear direction, because once they hit the atmosphere, they're going to slow down much quicker and they're going to get pulled away from you. They're not going to create a danger. So
the debris that we see here, is this from the skirting?
That's happening. Something's happening in the skirt. So either there was an impact, in which case there was some other piece of space debris that just like in this 1 in a billion chance, it just happened to hit. That's one theory. It just bumped into something. The others have bumped into a dummy.
That was my next question to you. It could have just been something else.
It could have been. I mean, maybe we'll find out. But the chance of that happening are just so remote. It's like, but it's not zero. Okay, so you have to remember there is a chance that something like that would happen. Now that's very energetic.
Most of the debris that you see flying around here, it looks as if it's coming from inside the ship.
Yeah. So either it could hit really hard on the outside, which just kind of caused all these things to break apart on the inside and just go around. But there seemed like there was there was almost an explosion. It looked like more than just a kinetic event. There was a flash there. And I don't know if, it would have to be quite a big kinetic event. And I don't think that the dummy link would have been able to do it because they would not have had that relative velocity to be able to do it. It could have bumped into it and, it wouldn't have caused any damage, It wouldn't even have scratched the surface.
It's not a question of mass, is it, in space? It's all about relative velocity.
Everything comes down to kinetic energy. Mass is one component of it, but there's the V squared part. So kinetic energy is 1/2 V squared. And so if you basically the V is going to be the relative velocities between the two. So if it's 1,000 kilometers per hour, and you got to convert that to meters per second and everything else, then you square that and you get a pretty big number when you square a velocity like that. And so even if it's a small mass, it's going to come in with a lot of kinetic force. The bigger the mass, the more. But the thing is, if it was like something very small, like a micrometeoroid, I don't think it would have been a big punch like that. So exactly. I think you need something with a certain amount of surface area, which means it had a certain amount of mass to it, as well as a certain amount of velocity. That's one theory. The other theory is like something just blew up. And so there was something in there. There could have potentially been a leak because this happened before. But the thing about like an explosion, especially in the vacuum of space, is that you need not only a fuel, but you need oxidizer. Oxygen. So if there was like a fuel leak, it's like so long as there's no oxygen, and up at that part of the atmosphere, I don't think there would necessarily be enough oxygen that it would be able to really create something like that. It could be wrong. I mean, you're seeing this a little bit there. So there's that possibility, but I'm not quite sure what it is. It could have also been, there was just some mechanical system that just kind of failed. There could be some COPVs that were in there that for some reason decided to give up. Another theory was like a blockage of a vent line that had some ice in it or something like that, and suddenly decided to let go.
Because we see a lot of heating going on here right now.
Yeah. There's heating. So I mean, that's the thing is that you do have an energy source, and the question is, do you have a fuel source and do you have an oxygen source? And then three of those, then you'll get a boom. But without that, it's kind of hard to tell. But we're speculating here because we don't really know much except to say that, that was quite an event. Now, if it was something going at the same velocity, it probably would have that would have been it. So it's possible if it was a kinetic event that the velocity differences, while substantial, would not have been 10,000 kilometers per hour or anything like that.
And that looks like a lot of, what would it be, insulation, or could it just be?
Oh, some of it looked like insulation. Yeah. I mean, because you see some things that look kind of fibrous, like a blanket, like right there. That looks like some kind of blanket material. That's all around, and you can see there's a lot missing down there.
Yeah,
and it's kind of weird. It's like, what was there before? It's like, was there a tank there that exploded? No, because you'd think if a tank exploded, then you would see the damage over where that was, and it seemed like it wasn't really anything down there.
Looks like metal.
Yeah. So it's all pieces of the skirt, it's pieces of the ribbing, any insulation they have around there, and it probably also went around and kind of tore up a few other things. But the thing is despite that, those engines were able to relight,
which is amazing.
Yeah. So it's like at that point, you're like, oh, probably something got ripped, and it's not going to be able to actually do the final burn, but it was able to.
And it just goes to show how confident, the takeaways are so great, so amazing for SpaceX from this, because, and if you look at the flap, now this is the rear flap, right? One of the rear flaps. Correct. And you see it, little bits and pieces kind of burning up, and the edge of it, the bottom edge of it being shredded as it enters the atmosphere. And that again goes to show that SpaceX has really, really pushed this beyond all limits, and it still survived. It still survived. That is so amazing.
Yes. And so they were taking it a bit steeper than they normally would, just to be able to test it out.
Flake off on the edge.
And it looks like a piece of fabric just dangling out there, and that's a piece of a stainless steel. Just flapping around like that, and you can see where the hot spot is. So that's something they're going to concentrate on. It's like, what do they do to reduce that? Maybe they just say, do we even need the flat material there in the first place? Would there be an advantage just going ahead cutting that out, since the plasma wants to leak around there? Is there some way we can just let it do it? Or is that just going to make the problem, move its way on up further on down? But you see the most important places, where the hinges are, they're not having a problem. So they seem to be well covered. It's just always in those edges. And, there's a reason why they call things edge cases. It's always at the edges where everything becomes a problem. It's interfaces between things. That's where stresses come up. That's where, leakage is going to happen, everything.
Right. And you see, this is the forward flap here. And you see a lot of, or is this the rear flap?
I think that's the rear. I think that's the rear. Yeah, we're looking from the forward flap back. Yes.
Right. But you see the sort of the pressure and stress that it's under, and it's still holding up. Yeah. Now
there's one theory there, is that when you kind of look back at there where it's burning, we're also seeing the skirt, because I'm not sure if where the skirt kind of came apart, where that was near where that rear flap was. And, that's the other possibility, is that maybe it's just something going on with the fact that those flaps were deteriorating, that they caused, some heating that then kind of caused the skirt to fail around that area. So when I was looking at that, I was seeing that, parts that were eroding away that were glowing.
This is after the explosion.
Yeah, this is after. But what you're seeing is like you now have that gap that's in the skirt, and it seems like that part is starting to also glow a little bit orange as well, which wouldn't surprise me, because now the flow and everything has been kind of messed up going around there. So it was a little bit later when we had that shot looking back towards the rear, we were able to see what looks like also a little bit of disintegration on the skirt where it was already compromised. And the question is, so it's not on that side. When we end up seeing on the other side, it does seem to be something's going on there. And that could be because it's now been, right there. It looks like more than the flap turning orange there to me. It looks like it's also in the skirt section.
The scale, yeah, exactly.
Yeah,
right.
Yeah,
right.
And that, so it could be that there's something connected between that flap and where that happened as well. Yeah,
it's a lot of it coming off.
Yeah. So so that side seems to be quite compromised compared to the other. There's definitely an imbalance.
It never ceases to amaze me just how well it held up despite all the stress and pressure.
Yes.
And then absolutely. You see this is the part where you see just how much of that flap is eaten up.
Oh yeah. There's not much left. Yeah, on that rear section now. Yeah,
and it's still actuating.
Yes,
it's still moving around. They can still control it, and it's still acting as a control surface.
And for the most part, that's what you would just call like a sacrificial surface. So it may be that that's going to be the name of the game. It's like, we just go ahead and make this section here that we just know is going to burn up, but maybe we design it in a way that's really easy to replace it when we come back on down. Right. And, this is kind of normal. If anyone that has a boat, they know there's something else they call the sacrificial anode. And the thing is that whenever you put something in salt water and everything else, and you've got two different materials next to each other, they just want to corrode. So what they do is you actually put something on there on your motor or on the hull of your boat that's actually intended to draw all the current, and it's sacrificial, which means it just gets replaced every couple of years, because that's what you want, where the corrosion is going to happen. And so you may do the same thing there. As you say, it's just going to get very, very hot there, and we just know that stuff's going to burn up. And maybe that's what we just do, is just go ahead and make, a 1 or 2 foot section of that sacrificial that will slowly burn, but under our control, the way we want it to do, and not because, the stainless steel can't handle anything else.
Interesting. So then what you're suggesting is that they could just swap out these flaps.
Maybe the end of it. Yeah, the end of it. Just pop something out.
Because for it to be caught by the chopsticks by Mechazilla, Mechazilla, remember, is not going to catch Starship by the flaps.
Correct. It's going to be catching it from the pins up the top. So the flaps are not going to be involved at all. And then, but now you want to relaunch it, and it's like, wow, man, we're going to have to replace all the flaps. And you say, oh no, what we just pop this section out, put in there, and maybe you make it out of some other material that, maybe you do make that out of like carbon composite or something like that. I don't know how well carbon composites are able to handle the heat versus stainless steel, or some of these other materials that Dr. Ed Pope had kind of talked to us about, that are able to handle, hypersonic kind of temperature regimes. So maybe they just say, okay, we'll make that out of this exotic material, or we'll make it out of something that's almost like a heat shield. I mean, just go ahead and put like a heat shield, honeycomb heat shield material there that's able to handle it and make sure it doesn't spread further through.
If you're listening, Dr. Bob, this is your cue to come back and talk to us about this.
Right. Now there is something else. It's like right at the landing, the other big mystery is, why did the orange bit. The orange bit. And there's a lot of theories here on what happened with the coloration, because it's like,
okay, can I just say something first, that I wish anybody at SpaceX, if you're listening, please put a gimbal camera on those buoys.
Yeah.
So that you get stable images, because you've got this little buoy out there flopping around in the waves, and then it's great. I mean, the fact that we can get these visuals itself is great.
It would be nice to also have,
but it would be really amazing if you can get a gimbal shot.
It would also be nice if they just had a drone on there that it would just launch before it came down, and just go up and then come back down to the buoy. So, and that would be a lot of invaluable engineering data. Yeah. Who knows? They may have that stuff. They're just not providing it for the live stream.
Yeah. All right. Mr. Orange Rocket.
What's going on there? Okay. So many different theories that are going on. First of all, is that the underside, or is that the top side? That is the underside. And part of the reason that is by looking at how the flaps are deployed back. So, they fold back that way, and that should be all black. So what happened? Did they get so hot that they changed their color? And more than likely, it's something got deposited on them. That seems to be the prevailing theory, is that something was on there. One is like something just kind of leaked and get deposited. The other that I'm kind of going more towards is that you'll notice that it's kind of symmetric coming down, and it goes up to a point.
Yeah.
Around there, they had different heat tiles. Some places they were missing, and some places they put some metallic tiles in there. And so it's possible that it came in.
I think I heard Elon mention that these are sacrificial tiles.
Yes, there could have been some sacrificial tiles there. And so it's possible. Now, I don't know that the stainless steel, if it was exposed. Now, remember, stainless steel does have a component of iron in it.
Yeah. And
if it was very hot, you could get some exotic reactions. And there was someone who's got a background in plasma physics who kind of talked about the possibilities that, it was like reactions with a very hot plasma that could be leaching out some of these materials and basically just depositing them, because plasma coating is a thing. And it's used to put very thin coatings of materials on top of stuff. So if you want to change the color or something like that, it could have come from it. So it may have been that, stainless steel has like iron, it's got chromium, and it, guess what? So yeah, nickel, iron, and chromium. But if something happens that you get this reaction and suddenly there's this iron out there, and you are in the atmosphere, so there is still some oxygen, maybe it rusts, and so maybe that's the rust color. The other possibility is that it could have been another material, because some of them may have been using copper or something like that. So whatever were those sacrificial ones that they were going through, that they ended up having a reaction with the plasma and putting it on there. And so what you now have is a thin coating. I don't think it means that the tiles were damaged. The question is whether they're reusable, whether you can just go out and spray that stuff off, or whether it's now actually compromised the surface, because ideally you do want them to be black. And part of the reason you want them to be black is that things that are black in color radiate heat really well.
Right.
So when they're getting hot, they're able to get rid of it a lot quicker. So that's part of the reason you have that coloring. So that's one of the theories. We don't know, and I'm sure we'll find out in the report. Now, the big mystery is like, why is the top white?
Yeah.
And
Do tell.
I'm kind of surprised that everyone is mystified. They don't know what it is. And I'm just going to go out and guess. I'm going to go like, oh, it's just the frost line. Because remember, there's the header tank.
You've got the header. You've got the
you
header
get the header tank up there.
Yeah,
okay.
of course.
And like, if you take a propane tank and you empty your tank, you know what happens?
Show us the model, Scott, so that we know what
gets
we're talking about. Show us the model.
Okay. So we got this beast right here. So what we have is that up at the very top inside of here is the header tank. So you've got a couple of fuel tanks, and one is you've got a reserve tank, right? You want to make sure you don't accidentally use up all the fuel, and now you don't have anything to be able to do a safe landing. So right. There is a reserve tank, and the other thing that's sitting up there, that is a sphere, and it's completely full. And that's the other reason, is you don't have to worry about sloshing or anything like that. So if you've got a partially empty tank, it's pretty tricky to start those things up sometimes, because it could be sloshing around. So that header tank is up there, and anyone knows if you take a propane tank and again empty it, that tank gets really cold really quickly. So these are cryogenics already, and now you're taking the cryogenic and then you're running all that stuff out, and you're out in the Indian Ocean, I think near the equator. I have a feeling it's humid. So there's a certain amount of humidity. There were clouds in the area and everything else. So my feeling is like that potentially could just be a frost line that's on there. And that would make sense for why it's white. I'm surprised I haven't seen anyone bring that up. And maybe it's because they're way smarter than me. And they're like, are you kidding? No way it's a frost line, So there's probably 1,000 reasons why it's not. But to me, I just thought that would probably be the reason, is that's what the tanks are.
That's fascinating. So let's talk Mars. How are they going to land on Mars? Is this?
Oh, that's interesting. So the only takeaway from the update, I mean, there wasn't much in the update. It was greatest hits again. But, updating the confidence of being able to hit the next two Mars windows. And the fact that they already have a customer, I think it's the Italian Aerospace.
The Italian Space Agency, yes.
Italian Space Agency. And they're going to send, a couple experiments to Mars. And it turns out, if I read it right, the experiments that they're putting up there are more about doing experiments on the way to Mars and not so much when they're at Mars. And then if they're able to actually land on Mars, that's a bonus. So the first one that they said was they're going to land on the skirt. Because, right now, the Starship does not have legs. They did an initial test, but they've scrapped the legs, and they don't plan on having legs at all. For at least for the Earth side of it, because they're going to be catching that. But you go to Mars,
that would mean the skirt would have to be really robust to withstand.
Yeah. Well, the other thing, remember, at this point you don't care because you're not coming home. It's a one-way trip. Sure. So part of it is like they're going to land in the skirt, but that raises a lot of challenges. Okay, and some of the challenges, of course, are that you've got the engines that are down here. When they light up, they're exhausting out, right?
Yeah.
And so when you come down that surface and you land on the skirt, suddenly there's no place for it to go. So just to remind everyone that, it's like, where's that going to go when you plant that straight in the ground? And remember, the whole thing about the interstage was that when you light that thing up, you want the exhaust to go somewhere. Yeah. And that's why you have that vented ring that's there. So now when you plop this down, I like this, like you're coming down.
Yeah.
And it's coming down the surface, and then you want to slowly bring it down and then touch down and then shut it off. what happens to all that exhaust?
Before you touch down.
Yeah. Well, if you shut it off before you touch down, that means you're gonna suddenly fall. So at some point you have to make sure there's enough, and maybe you say, okay, it's only 1/6 gravity, I don't mind. The other thing is that part of the reason the legs is they are shock absorbers that will be able to kind of catch it as well as level the whole thing. Now, something people don't realize is that, you know why all those recent Mars landers have been falling over? And like, oh my God, we saw this back in the mid 60s with Surveyor and stuff like that. You know, what's wrong? Why can't they do it? And it's because back in the 60s, they realized that when you go to a lower gravity environment, tall things tend to become less stable, not more stable. And that's why the Surveyor was very broad and wasn't very tall, had a very low center of gravity. And everyone knows that. If you get a low center of gravity, it's much easier to remain stable. However, now here in the 21st century, everyone is just so confident with how good their control systems and everything are. They think they can take a really tall tower like this and drop it down onto any sort of environment, even a low G environment. And you might be wondering, so wait a minute.
You've got most of the mass. That's the engines. So most of the tanks, including the header tank, have been expended, right? The fuel has been expended, right?
Yep.
So most of your mass is anyway at a much lower point.
But you get cargo up here too. Remember, your cargo is way up here. Correct. So even though you've expended that, well, a couple hundred tons, right? So the main thing is that what happens on a low gravity kind of environment is that your weight decreases in gravity. What does not decrease is inertia. So what ends up happening is if you get a tipping moment like this, you're hoping that gravity will take over and begin to bring you back to center. So if something happens that bumps into it, I now have angular momentum. And I need to check that angular momentum with a counter torque. And what's creating the counter torque is the fact that I've got a gravitational vector going through my center of gravity, which hopefully is going to pull me back over to where I need to be. If you make that 1/6, then suddenly that means you have less. And that's why they're falling over on the surface of the moon is like, you are lighter, but inertia is inertia. It doesn't matter. It has nothing to do with the gravitational field.
It's going to be any chance they'll change their mind about landing legs?
Oh yeah, they are. And the one after that, they plan it, because the one after that, they actually plan on bringing cargo. And that means they want to land safely. So what they may be looking at, say, we're probably not going to make it down to the surface anyways. Why are we even bothering with the legs?
You might as well, if you aren't betting too much, or if it's just an experiment and you want to see the outcomes, why not put landing legs on the first one?
And part of it might be, but there's the other thing is that, I'm pointing out all these things that are wrong with it, which means it's like, I'm accusing all these SpaceX engineers of not having thought this through. It's like, they've thought this through. And one of it is like, they don't really care if they just kind of plant that thing in. It doesn't matter that the skirt gets all crumpled and everything else. Maybe it actually goes in the ground pretty hard. The only thing I'd be concerned is like bouncing back up and then going unstable and falling over. And then I'd say, it doesn't matter. We'll call that a win, because we'll have a few experiments on there. Maybe we'll have a couple of optimi that can come out. And it just kind of tips over in whatever. And they're going to be maybe sending a few. So maybe one of them will make it.
For you. Here's a question for you. Considering that gravity is 1/6 that of Earth, if it tips over, how much of a damage would it be to the hull, to the body of Starship? Would something a couple of optimi inside, would they be able to survive?
They might be able to. They might be able to. And it's just hopefully. Yeah, I mean, usually when these things are falling over, we're seeing them go boom. Because of the residual fuel that's in there. I'm wondering if that's intentional. I can't believe it's just like it falls over and explodes. It could be that they just set off the FTS at that point because that was the best time to do it, to make because they want to sink them anyways. They were not attempting to recover them, so that's probably why they went. So hopefully,
set off the FTS, considering the distance and the delay, because you don't have Starlink, you're still.
It would do it autonomously. So it probably wouldn't do that. I mean, at this point, the FTS was turned off probably as soon as they left Earth orbit. They don't care. And when it's landing, the question is if it falls over, if there's going to be a tank rupture, is anything going to happen to be a problem? Well, the fortunate thing is there's no oxygen to worry about on Mars. So if fuel spills, we don't have to worry about that. And it's methane anyways. All we're doing is we're just basically adding it back to the atmosphere already. So then and so the main thing will be, is like, if we can just plant something on down there, and even if it's a rough landing, they're going to call it a victory, because there's no human cargo on there, and there's no cargo that they're using for setting up that. Now the next one,
it's all expendable.
They are using it's all kind of expendable, and it may be just looking at the timelines. The other thing they could be doing is, I was trying to look closely at the images, is that, you know, the HLS has got the same problem as well, the human landing system for the moon. And you know, they do have landing legs on it, but the thing is, they are going to be using actually thrusters up here, up at the top, not at the bottom. So it could be that the main engines are just going to slow that thing down, and then when you're like a kilometer up or something like that, it just stops burning, or maybe a couple hundred meters up, and then the final kind of touchdown is just done by what will be some sort of thrusters up at the top. And again, I want those thrusters up there for another reason, and that is, if I start to go timber, I want that thing riding it back up. So I'm pretty sure they would have to have something to make sure. And that
would mean you'd have to have them on 3 axes.
Yes. Yeah, you'd want to have enough. So you'd want to have at least 3 of them around there. And knowing SpaceX, that's what they would do to absolutely minimize the number you have on there. Normally, everyone likes to have 4. So you get like something this way and something that way. But yeah, I would think if you had something like that, you would have enough control that if it starts to tip over, and you don't care if it comes in like the Leaning Tower of Pisa. It'll be like, that's fine, you know, it's like that. So long as it's not going to tip over, we're kind of get it to a certain position that it's still stable. We get our cargo off and everything else, and we know what the challenges are going to be. But more than likely, if it comes in like that, I mean, they're going to be looking for ground that is pretty level. And so I'd be kind of surprised if, you know, suddenly they find, you know, the original Apollos were on very level surface, and it was like the later ones that they decided to go the real challenging ones.
Yeah. But the other thing I was thinking about was, if with the first arrival on Mars, do you remember what happened with, I think it was the second or the third attempt to land Starship, and it landed, and then there was residual gas, and that exploded with the heat, and Starship blew up after it had landed.
Yeah. See, I mean, there are 1,000 things that can go wrong. So, you know, that would be one of them. And, you know, certainly coming down and capturing gas in your skirt would be kind of dangerous. You want to have some way of venting it. So my suspicion is that if they really want to be successful, is like right near the bottom, they're going to make sure there's nothing they can capture. Or, you know, they may have some other vents on there that we're not going to see. It doesn't take that much to vent, right? So maybe they're just going to poke a few holes around here. And that's assuming that you have like a perfect seal when you go down. So there's probably plenty of ways that maybe the gas will be able to escape.
Yeah, because there's very little atmosphere, next to no atmosphere on Mars too. Okay?
Yeah. But the last thing you want is like, you kind of put it on down there and you're still venting, because remember, these things don't shut down instantaneously. You kind of get on there and suddenly you burp, you know, and then it goes over because of that. So those are like the little details that you want to be careful of. And of course, the main thing it might be is like, are you kidding? It's like, you know, this thing has got so much inertia and mass that it would take a lot to even move it a little bit.
Well, we'll know when we know. That's going to be something. I wonder if you'd get a live stream of that. That would be fascinating, wouldn't it?
It will be. Do you think it'll be a delay stream? It won't be a live stream.
Okay. Do you think? Well, they could always deploy a few Starlink along the way at one of the Lagrange points.
Yeah, but it'll be a delay. It'll still be like a 20-minute delay by the time we see it. So.
Yeah. But I mean, they don't need to. They could just keep orbiting for a while before they start their descent, even with the first launch, right?
I'm assuming. I don't know if they're going direct to surface on the first one, because you know, ideally you would like to somehow capture yourself, but that's going to require a burn to be able to do that, and then, you know, second burn. So the question is like how much fuel reserves you have. The other is that you just go direct, and that you don't bother going into orbit. You just go straight into the atmosphere, and that slows you down. And then, you know, I'm not sure if they're going to be able to figure out how to do a maneuver that you hit the atmosphere and have that slow you down enough, and then put yourself actually into an orbit without expending any propellant, or maybe very, very, very little. But now that you get yourself in orbit, it's like, now we're going to deorbit. So that's going to be an extra burn. So the most energy efficient way is just go straight in. Don't bother going into that orbit. That's going to Yeah, it's going to be a bit more costly. It's already going to be a challenge. Like they're bringing cryogenics with them all the way on like a 6 to 9 month journey, and that you're going to have a certain amount of loss of the cryogenics. So you have to do something to keep them at those cryogenic temperatures, because there's going to be boil off, and so your margins are going to be pretty thin already.
All right, one final look at the orange rocket, and then we'll call it quits for right now. Thank you so much, Scott. It's been a pleasure chatting with you. As always, your insights are fantastic, fabulous, and just so educative. Thank you so much for joining.
Okay, thank you.